Discussing about basics of machine learning. So initially we'll start with some basic definitions, and then I'll move on to the more advanced stuff. So machine learning is a way for computers to learn patterns from data instead of being explicitly programmed with rules. For example, instead of coding if temperature greater than 30 predicts summer, we give the model examples of temperature versus season, and it would learn the patterns by itself. Now, formal definition is ML is the process of learning a mapping function fx that best maps input x to an output y by minimizing some loss function L y comma fx. And theta here stands for model parameters or the weights. Now the model learns theta by minimizing the loss function, that is minimum of L y comma fx comma theta, fx of theta. Now real world example would be input x number of rooms, location or area, output y is the house price, and goal is learn fx that predicts price for unseen data. Now what is the difference between AI, ML and deep learning? So AI is basically a broad field of making machines intelligent. For example, ChatGPT and different types of LLMs, autonomous driving. ML is the subset of AI that learns patterns from data. That like there are machine learning models like linear regression, logistic regression, SVM, random forest, right? Then we have deep learning (DL), which is a subset of machine learning. It uses multi-layered neural networks, for example, CNN, RNN, transformers, etc. Where CNN stands for convolutional neural networks, RNN is recurrent neural networks, etc. Now, what are features and labels? Features are input variables X that are also known as predictors, while labels are output variables or Y, which denote the target. So for fake news detection, features are the words, metadata, images, which are labeled as fake or real. Now, what are the three main types of ML? So we have three main types of machine learnings. First is supervised learning, which basically learns from labeled data. For example, spam classification or price prediction. Then we have unsupervised learning, which finds patterns in unlabeled data. For example, clustering, news, topic modeling, etc. Then we have reinforcement learning, which learns via reward and penalty, like self-driving car, AlphaGo, etc. Now, what is the difference between regression and classification? So regression is basically it gives an output as it gives outputs as continuous values, while classification gives outputs as discrete categories. Right? In classification tasks, we are able to classify different categories or classes, while in regression we get continuous values. For example, in predicting temperature. In classification, we get fake or real news detection or spam or not spam. So we basically are able to get discrete categories. Now, key difference is that regression predicts a quantity, while classification predicts a category. Now, what are the key steps in an ML pipeline? So first is data collection, then data cleaning and pre-processing, then feature engineering, then model selection and training, then model evaluation, then hyperparameter tuning, then deployment, and finally monitoring and maintenance. Which step takes the longest? So the data pre-processing and cleaning takes the longest time. Now coming to the machine learning model, so linear regression is the first one. The concept is that it fits a line or hyperplane that best represents the relationship between input x and output y, and it is a linear relationship. So you get this relationship: y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus up till beta n xn plus constant epsilon. Now the goal is to minimize the mean squared error, that is MSE, which is 1 by n summation yi minus yi cap whole square. So predicted minus actual output value, target values, and the square of that. So we are finding the line of best fit that minimizes the average square distance between actual points and the predicted line. Now training via gradient descent. So we start with random weights, compute prediction, that is find the error, and adjust the weights by this formula. Repeat until convergence, where alpha is the learning rate. Some interview question answers. So why do we minimize squared error instead of absolute error? Because squared error is differentiable and penalizes large errors more strongly, making gradient descent easier. Squared error is minimized instead of the absolute error because it is differentiable and penalizes large errors more strongly, which helps in gradient descent becoming easier. What assumption does linear regression make? So the first assumption is that there is linearity between x and y, the feature and the target. No multicollinearity, we have all independent features. Then homoscedasticity, that is we have equal variance, and normal distribution of errors. Now moving on to the second model, that is logistic regression classification. So it predicts probability of a class 0 or 1 using the sigmoid function, which is p is equal to 1 upon 1 plus e to the power minus z, where z is the same formula that we have for y that we use in linear regression. The same formula is here. Decision boundary of p greater than 0.5, then we have class 1, else class 0. Loss function is cross entropy, so the cross entropy loss is L is equal to minus 1 by n, y log p plus 1 minus y log 1 minus p, where p is this value. So minimizes difference between predicted probability and the actual label. Now, why use the sigmoid instead of the linear output? Because sigmoid maps any real number to 0, 1. So the range is actually reduced to 0, 1, and it is a standard range, and this makes it interpretable as a probability. Can logistic regression handle multiple classes? Yes. One versus rest or softmax regression, multinomial. Now, overfitting versus underfitting. So overfitting means that the model learns the noise from the trained data. That is, it does not generalize well. It basically learns all the data from one sample, and it is not able to generalize to other test models, right? And symptoms are high training accuracy and low test accuracy. Fix is regularization, apply, drop out, or get more data. And then we have underfitting, where the model becomes too simple. So symptoms are low train and low test accuracy. Fix is make the model a bit more complex, add more features, right? So you can understand overfitting and underfitting using an analogy. Overfitting is basically, let us say we have to prepare for an exam and we are given a book that we have to read from which questions will come, right? So there are two students, right? The first student completely wrote learns the book, like every single excerpt from the book and all the questions that were mentioned in the book. He learns them exactly word to word. And during the exam, what happens is the questions are tweaked in a way that you have to analyze them, and they're not the same as the questions that were in the book, right? So the first student who has learned exactly like word to word things and who does not really think out of the box, who just sticks to the textbook and coursework as allotted to him, is not able to generalize to other questions that have been asked, right, to test their analytical thinking. So the first student example shows how overfitting works, because the first student is not able to write the answers because the questions were different, right? So basically, the what has happened is that he has been able to understand the context of the book, but not able to generalize it to different types of questions that are being asked based on the book. So that is a case of overfitting. And in case of underfitting, the model is too simple, or you could say the second student who was asked to prepare the questions from the book, does not do the questions, and in the answer paper, he just is basically able to write only the basic things that he has learned, right, and is not able to generalize, or basically not able to understand the full complexities, or understand in depth what the paper is asking, right? So that is an example of underfitting. So I hope you understood by that analogy. Now, underfitting is basically a straight line on nonlinear data. Overfitting is a wiggly curve passing through every point for the training data. And ideal would be a balance between both. Now, moving on to regularization, we have L1, L2, and elastic net. So L1 is also known as a lasso. The equation is mean squared error plus lambda times summation of weight, right? So absolute weight. And L2 in ridge regression, we have MSE plus the lambda of the summation of weight square. So it shrinks weights smoothly. In lasso regularization, we basically can shrink some coefficients to zero, while in L2, we are not able to shrink coefficients to zero. We might be able to reduce them, but we don't completely reduce them to zero. So it is also said that in L1, since we are reducing some weights, some coefficients to zero, we are actually performing feature selection, where we want the insignificant features to go out of the equation and only consider the significant features. But in L2, we are not performing feature selection because we are not reducing the coefficients to exactly zero. We're just shrinking them. And then we have elastic net, which combines L1 and L2, so we get the best of both worlds. Now, intuition is adds penalty for large weights, discourages complexity, and prevents overfitting. This is what regularization does. Why does lasso drive weights to zero? Because absolute of weight has a sharp corner at zero. Optimization prefers exact zeros. Then why use ridge if lasso can do selection? So ridge is better for multicollinearity and continuous shrinkage. Now these are some parameters, the evaluation metrics. So we have accuracy, precision, recall, F1 score, and ROC, AOC. So precision is how many predicted positives were correct, and recall is how many actual positives we got, right? And then you can